Hey everyone, welcome back to the channel. Today we are diving deep into one of Python's most powerful features, iterators. If you have ever used a for loop, you have already been using iterators, but there is so much more to them than meets the eye. Iterators are all about traversing sequences efficiently, one element at a time, without hugging the memory. In this video, we will explore how iterators work under the hood, build our own custom iterator, and see how they shine in real-world Python projects. Let's get started by some theory. Iterators enable memory-efficient traversal of sequences, yielding one element at a time. They are designed to traverse sequences like lists, strings, or custom data structures in a memory-friendly way by yielding just one element at a time, as our slide highlights. They implement the iterator protocol with iter and next methods. Iter method returns the iterator object, and next method provides the next value or signals completion with a stop iteration exception. They are used in loops and custom data structures for scalable, lazy evaluation, meaning they only compute values when needed rather than loading entire datasets into memory. This makes them incredibly powerful for real world applications such as processing massive files, like reading a multi gigabyte log file line by line, or traversing complex data structures like yielding nodes from a graph in a social network analysis tool. Let's start by building a custom square numbers iterator. To really understand iterators, let's create a custom one from scratch. Suppose we want an iterator that generates square numbers up to a given limit. We will define a class that implements the iterator protocol. We have already seen classes, so define a class. Let's define class square numbers. Define its constructor init self max num and self dot max num equals max num. Self dot current equals 1. After that, we should define an iter method which returns self, marking this object as an iterator. So let's define it. Def iter self return self. We should also define a next function. If you recall from the slide, the next method checks if we have exceeded max num. If we have, it raises stop iteration to signal the end. Otherwise, it should calculate the square of the current number. Next, self. If self dot current greater than self dot max num, it should raise stop iteration. Now let's define square equals self dot current raised to the power of 2 self dot current plus equals 1 and return square. So let's test our custom iterator. Squares equals square numbers 5 for num in squares. Print num and let's run and see the results. As you can see, until 5, it prints the square of numbers. If you wonder how it works, here iter calls iter method and each next call invokes next method. When we hit the limit, calling next again would raise stop iteration as defined here. It raises stop iteration exception. So this manual control is great for understanding, but most of the time you will use iterators in for loops for simplicity. If you make it 10, it will go up to 10. So as you can see, the result is different this time. Let's also try a custom range iterator. Say class custom range and define init self start, end, end, and step. A self dot current equals start, self dot end equals end, self dot step equals step. And iter function should be like this, only return self. And now the next function, define next self if self dot current greater than or equal to self dot end, raise stop iteration. Similar to previous one, value equals self dot current, self dot current plus equals self dot step, and return value. Now let's use it. Let's type for num in custom range 0, comma 10, comma 2, print num, and run it. As you can see, this mimics Python's built-in range but gives us full control. It's a great way to see how iterators let you customize traversal logic. So everyone, that's it for our deep dive into Python iterators. We have seen how they work under the hood with iter and next, built custom iterators for squares and ranges, and explored their usage. Iterators are a fantastic tool for writing memory efficient, scalable code, and I hope you are excited to try them in your own projects. Let me know in the comments if you have any questions. If you enjoyed this, give it a thumbs up, share it with your friends, and subscribe to the channel to not miss out anything.